everyone, welcome to the Exponent Properties Guide and Notes. This is the first page of your notes. However, we're going to skip this page for now and go back and do it at the end. So let's flip to the next page. It says, let's analyze the product of powers. Remember that x to the fifth equals, we're going to write this out. So x to the fifth equals x times x and times x 5 times. Now let's write out x to the fifth times x to the third. So x to the fifth is x being multiplied by 5 times, and then x to the third is 3 more x's. So this can be written as, if we add these all together, we actually have x to the eighth. A to the eighth times a to the second. Let's write it out. So we have 8a's multiplied by 2a's. This also can be written as, so if we add these all together, I have 10a's. Let's look at this one. M cubed times n to the fourth. So we have m being multiplied by 3 times, and then we have another m, and then we have 4 n's. So this can be written as, if we combine it together, we have 4 m's, or m to the fourth, then we have 4 n's, n to the fourth. So we have m to the fourth times n to the fourth. Summarize the above information in the following table. Okay, so x to the fifth, x to the third was x to the eighth. A to the eighth times a to the second was a to the 10th. M to the third times m times n to the fourth was m to the fourth times n to the fourth. Analyze the above table. What shortcut could you use to determine the product of powers? So to figure these out, we wrote them out, and that will work. But sometimes we don't want to always write them out. So we're figuring out, how can I get from here to here without having to write it out? And if you notice right here, so 5 plus 3 is 8. 8 plus 2 is 10. Now right here on this last one, the power for that second m is a 1. You don't usually write out the 1. You just assume it's a 1. So I added 3 plus 1 and got 4. And my n to the fourth is a separate power. So if powers with the same bases are multiplied together, you may add the exponents. So in summary, x to the m times x to the n would be x to the m plus n. Let's practice down here. It says simplify the following expressions. Y to the second times y to the seventh would be y to the 2 plus 7, which would be 9. M to the third times m to the 10th would be m to the 3 plus 10 would be 13. C to the fifth times x cubed, those do not have the same bases, so there is nothing yet you can combine. It would be c to the fifth, x to the third. 2 times x to the 8 times x to the 7, our 2 would stay there. X to the 8 plus 7 would be x to the 15th. 3 to the a to the 9th times a times b to the 11th. Remember that power there on the a is a 1, so it would be 3 times a to the 9 plus 1, which would be 10, times b to the 11th. X to the 101st times x to the 99th would be x to the 101st plus 99, which would be x to the 200. Now we're going to look at a power to a power. Write out in words the meaning of x to the second to the third. And that's going to mean x squared is multiplied by itself 3 times. We are going to write out x squared cubed. So that means I have x squared 1 time times x squared 2 times x squared 3 times. This can also be written as x to the 6, because I have 6 x's. Write out a to the 6th squared. So I have a to the 6 once times a to the 6 one more time. This can also be written as a, and I have 12 a's there, so a to the 12th. Write out m squared 4 times. So I have m squared once, m squared twice, m squared 3 times, m squared 4 times. This can also be written as m to the 8th. Summarize the above information in the following table. So x squared cubed was x to the 6th. A to the 6th squared was a to the 12th. M squared to the 4th was m to the 8th. Analyze the above table. What shortcut could you use to determine a power to a power? So let's look at this, for example. I have x squared cubed, and that gives me x to the 6th. I have a to the 6th squared, which gives me a to the 12th. M squared to the 4th gives me m to the 8th. So I'm looking for a connection between these powers. And if you notice, if I multiply them together, I can get the exponent for the power. So if a power is raised to a power, then you may multiply the exponents. In summary, power to a power. So if I have x to the m to the nth, that would be x to the m times n. Simplify the following expressions. Y to the 2nd to the 7th. So that's going to be y to the 2 times 7, which is 14. M to the 3rd to the 10th is m to the 3 times 10, which is 30. C to the 5th to the 5th is c to the 5 times 5, which is 25. X to the 8 to the 7th is x to the 8 times 7, or x to the 56th. A to the 9th to 11th is a to the 9 times 11, which is 99. And x to the 10th to the 20th is x to the 10th times 20, which is x to the 200th. Now we will evaluate powers of products. First, we're going to explain how 2 times x to the 5th is different from 2 to the x to the 5th. With the first expression, the exponent is not applied to the 2. You see that because the 2 is not in parentheses. In the second expression, the exponent is applied to the 2 because the 2 is inside the parentheses. Write out 2 to the x to the 5th. So that means I have 2 to the x once, 2 to the x twice, 2 to the x 3 times, 2 to the x 4 times, 2 to the x 5 times. This can also be written as, so if I'm multiplying all that together, I have 2 times 2 times 2 times 2 times 2, which is 32, and then I have 5 x's, so 32x to the 5th. Write out a to the b to the 6th, so I have ab once, ab twice, ab 3 times, ab 4 times, ab 5 times, and AB 6 times. Another way to write this, if I combine like terms, I'm going to combine all my A's. So it's A to the 6th, and then combine my B's is B to the 6th. Write out 3 times m times n squared. So I have 3mn times 3mn. This can also be written as, so I can multiply 3 times 3, which is 9. My m's combined would be m squared, and my n combined would be n squared. Summarize the above information in the following table. So 2 to the x to the 5th is 32x to the 5th. A to the b to the 6th is a to the 6th, b to the 6th. 3mn squared is 9m squared, n squared. Analyze the above table. What shortcut could you use to determine the power of products? So I'm looking at a relationship between these right here. Is there anything I can do that will help me to know what it is simplified rather than writing it out? If a product of 2 numbers or variables is being raised to a power, then the power is applied to each part of the product. So the power is going to go to each part of the product. In summary, power of products. X times y to the m is the same as x to the m times y to the m. Practice. Simplify the following expressions. x times y to the 7th is the same as x to the 7th y to the 7th. 2 to the m cubed is the same as 2 cubed m cubed. 2 cubed is 8 times m cubed. 2 times ab to the 5th. Notice that the 5 is not being applied to the 2 because the 2 is not in parentheses. So the 2 will remain the same, and then we have a to the 5th, b to the 5th. C times d to the 11th is the same as c to the 11th, d to the 11th. 3 times a cubed. So in this one, the power 3 is being applied to the 3 inside the parentheses. So it's 3 cubed and then a cubed. 3 cubed is 27 times a cubed. 3 times mn to the 20th. Again, the 20th is not being applied to the 3, so that just says 3. M to the 20th, n to the 20th. Now we will analyze quotient of powers. Simplify 2 over 2. So 2 divided by 2 equals 1. X divided by x equals 1. So this is reviewing that anything divided by itself will always equal 1. Write out x to the 5th over x cubed. So I have x times x 5 times on the top in the numerator. Then I have x cubed, or x times x in the denominator. If you notice, I can actually cancel out x divided by x. That's going to give me 1. So x divided by x is 1, x divided by x is 1. And I say cancel out because if I just cross them out, it's just going to give me 1, and that's not going to change the value of the expression. So I have what's left. I have x squared on top. Write out a to the 8th over a squared. So I have 8 a's on top. On the bottom, I have a times a. Now look what's going to cancel out. I have a divided by a divided by a. Those will cancel. What I have left over is a to the 6th in the numerator. So a to the 6th. Write out m to the 4th over m cubed. So on the top, I have 4 m's. On the bottom, I have 3 m's. What's going to cancel? I have m over m, m over m. Those will cancel and give me 1. I have another one. I have an m left in the numerator. Summarize the above information in the following table. So x to the 5th over x cubed was the same as x squared. A to the 8th over a squared was the same as a to the 6th. M to the 4th over m to the 3rd is the same as m. Now I don't need to write power of 1 there, but there is a 1 there that I don't see. So I'm just going to write m to the 1st equals m, just so we're aware. Analyze the above table. What shortcut could you use to determine the quotient of powers? So I'm looking at this right here, like the exponents. What do you notice about the exponents, the relationship between them? If powers with the same base are being divided, you can subtract the exponents. So the numerator minus the denominator will give me my new power. So 5 minus 3 is 2. 8 minus 2 is 6. 4 minus 3 is 1. Summarizing the quotient of powers. If I have x to the m over x to the n, so they have the same base, then that is the same as x to the m minus n. Simplify the following expressions. Y to the 7th over y squared is the same as y to the 7 minus 2, which is 5. M to the 10th over m cubed is the same as m to the 10 minus 3, which is 7. C to the 5th over c to the 5th. Well, I can actually just cancel all of those c's out. Once I cancel out all the c's, I would have left over 1. X to the 8th over x to the 7 is x to the 8 minus 7, which is 1. I don't need to write x to the 1st. I can just write x. A to the 11th over a to the 9th is a to the 11 minus 9, which is 2. X to the 20th over x to the 10th is x to the 20 minus 10, so x to the 10th. Write out in words the meaning of c over d to the 4th. This means the quotient of c and d multiplied by itself 4 times. Write out x divided by y to the 5th. So I would have x divided by y once, x divided by y twice, x divided by y 3 times, x divided by y 4 times, x divided by y 5 times. This can also be written as, so on the top I have x to the 5th, on the bottom I have y to the 5th. Write out a divided by b cubed. I would have a over b once, a over b twice, a over b 3 times, which would be the same as a cubed on top and b cubed on bottom. Write out m over 3 squared. I have m over 3 once, m over 3 twice. So combining like terms, on the top I have m squared. On the bottom I have 3 times 3, which is 9. Summarize the above information in the following table. X over y to the 5th is the same as x to the 5th over y to the 5th. A over b cubed is the same as a cubed over b cubed. M divided by 3 squared is the same as m squared over 9. Analyze the above table. What shortcut could you use to determine the power of quotients? So I'm looking at these exponents right there. What do you notice between a relationship between them? If a quotient is being raised to a power, then the power is applied to each part of the quotient. So this 5 would be applied to the x and to the y. Same thing with the 3, applied to the a, applied to the b, and the 2 is applied to the m and to the 3. So the power of quotients rules. If I have x divided by y to the m, that is the same as x to the m over y to the m. Practice. Simplify the following expressions. X divided by y to the 7th would be x to the 7th over y to the 7th. M divided by n to the 10th would be m to the 10th over n to the 10th. C divided by c to the 5th is c to the 5th over c to the 5th, which is 1. 2 divided by f to the 4th, so that would be 2 to the 4th over f to the 4th. 2 to the 4th is 16, and then f to the 4th on the bottom. A to the 3rd over 3 to the 3rd, so a to the 3rd over 3 to the 3rd would give me a to the 3rd, and then 3 cubed is 27. C over d to the 99th is c to the 99th over d to the 99th. Now we're going to be talking about negative exponents. Analyze the table below. What pattern do you notice on the second row going from right to left? So if I look at this second row right here, what's going on from 32 to 16 and then to 8 and then to 4 and then to 2? What's happening between those numbers? You should notice that each number is being divided by 2. Continue this pattern to complete the table. All right, so I have 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1, divided by 2 is a half, divided by 2 is a quarter, divided by 2 is 0.125, divided by 2 is 0.0625, divided by 2 is 0.03125. So I just kept dividing by 2. Complete the third row by rewriting all decimals as fractions. 2 divided by 2 is 1, and 1 divided by 2 is a half, divided by 2 is a fourth, divided by 2 is an eighth. Keep going, divided by 2 is a 16th, and then divided by 2 is 1 over 32. Any number to the 0 power, so I'm going to look right here. Any number to the 0 power equals 1. Because any number divided by itself will always equal 1. And notice up on this table, the base is 2. That's why I'm dividing by 2, because of the base right there. So if the base was 3, I would be dividing by 3. If the base was 4, likewise. But when I get here to the 0 power, it's always going to give me 1, because this will be the base, and I'll be dividing it by itself, and that will give me 1. What relationship do you notice between the top row and the bottom row? The bottom row is the reciprocal of the value of the base to the positive exponent. So you should notice that 2 to the first is 2, but then 2 to the negative 1 is the reciprocal, 1/2. 2 squared is 4, 2 to the negative 2 is the reciprocal 1/4. 2 cubed is 8. 2 to the negative 3 is the reciprocal of 1/8. Continues 2 to the 4 is 16. 2 to the negative 4 is 1/16. When simplifying exponents, all exponents must be positive. If a numerator contains a negative exponent, and we want it to be positive, then we're going to switch the power to the denominator, and the exponent switches to positive. If the denominator contains a negative exponent, then switch the power to the numerator, and the exponent switches to positive. So in summary, x to the negative m is the same as 1 over x to the m. A to the negative 4th would be 1 over a to the 4th. That's the same thing, and my exponent's positive. However, if I have 1 over a to the negative 4, I want the a to the negative 4 to be positive, so I'm going to flip it and put it in the numerator, and then I have a to the 4th. C to the negative 3rd over 5, I want the negative 3 to be positive, so I'm going to put it in the denominator. And I still have my 5 on the bottom. That generally goes before the variable. And in the numerator, I'm just going to write 1. 2 over 5 times m to the 0. So 2 over 5, m to the 0 is 1. So 2 over 5 times 1, which is going to give me 5. Now we're just going to talk about simplifying exponents completely. An expression with exponents is completely simplified when, number 1, all exponents of variables are positive. Number 2, all numbers are in the simplest form. Number 3, all powers with like bases are combined. Number 4, no parentheses. Analyze whether the expression is completely simplified or not. If so, write simplified. If not, write why the expression is not simplified completely. So if I'm looking at this right here, I have no negative exponents. I have all my numbers in my simplest form, meaning I can't reduce these at all. All powers with like bases are combined, and there are no parentheses. So this expression is already simplified. 4 times a to the 9th over 12 times a to the 5th. All exponents of variables are positive. Yes. The numbers are in simplest form. I can actually reduce 4/12, so those are not in simplest form. All powers with same bases are combined. A to the 9th over a to the 5th. That needs to be combined. And there are no parentheses. Let's look at this one right here. All exponents of variables need to be positive. I have a negative exponent right there. All numbers are in simplest form. 2 over 9, that cannot be reduced. All powers with like bases are combined. I can't combine the m's and the n's, and no parentheses. There are parentheses here. Last question. No negative exponents, which is good. All numbers are in simplest form. Yes. All powers with like bases are combined. C and the D cannot be combined, and no parentheses. So this one is already simplified. All right, I need to simplify and state the property used. So it's going to take a couple of steps to simplify. You may simplify in a different order than I do, and that is okay. I'm going to first simplify using the product of powers, and I'm going to add those exponents because I have the same basis here. So 2 cubed times 2 to the negative 5th is 2 to the 3 plus a negative 5, which is 2 to the negative 2. And that was the product of powers. Now I have a negative 2, which I want to make positive, so I'm going to flip it to the denominator. So I have 1 over 2 squared, and that was using the idea of negative exponents. And then I need to simplify 2 squared, which is 4. So that is 1 over 4, and that is by the definition of exponents. Now we're going to do the same thing to x to the 4th to the negative 3. I have a power to a power here. So I'm going to go x to the 4 times negative 3, which is x to the negative 12, and that was a power to a power. Now I need to get rid of my negative exponent, so I'm going to put it in the denominator since it's in the numerator. So that's going to give me 1 over x to the 12th, and that is because of negative exponents. All right, that completes the last page. Now we're going to go back to the first page and simplify everything that we've learned. Product of a power. When multiplying powers with the same base, you add the exponents. X to the third times x to the fourth equals x to the 3 plus 4, which equals x to the 7th. Power to a power. When a power is raised to a power, then multiply exponents. So if it looks like x to the third to the fourth, that is x to the 3 times 4, which is x to the 12th. When there is a power of a product, then apply the exponent to each part of the product. So I have x times y to the 4th. That is the same as x to the 4th times y to the 4th. Quotient of powers. When dividing powers with the same base, subtract the exponents. X to the 6th over x to the 4th is the same as x to the 6 minus 4, which equals x squared. Power of a quotient. When there is a power of a quotient, apply the exponent to each part of the quotient. X divided by y to the third is the same as x to the third over y to the third. Negative powers. When a base is raised to a negative exponent, take the reciprocal of the power. So x to the negative 3 is the same as 1 over x cubed. All right, everybody, that's it for today. Have a good one.